Until now, we have been deploying our application using multiple Kubernetes YAML files. That works, but real projects quickly become difficult to maintain. In this episode, we'll package our entire application as a Helm chart. By the end of this video, you'll be able to install, upgrade, and remove an application using a single Helm command. Our Students Portal application has 3 layers: Frontend, Backend, PostgreSQL database. To deploy everything, we needed several Kubernetes resources: deployments, services, ConfigMaps, secrets, PVCs, and an Ingress. Every resource was managed individually. As applications grow, managing many YAML files becomes harder. Every environment needs changes. Every update requires editing multiple files. Reusing configurations becomes difficult, and there is no simple release management. This is exactly the problem Helm solves. Helm is the package manager for Kubernetes. Instead of applying many YAML files manually, we package everything into a Helm chart. Then, Kubernetes resources are generated automatically from templates: one chart, one command, one release. Let's move to the terminal and build the chart together. We will create a Helm chart, move our manifests into templates, create a values file, install the application, upgrade the application, and finally remove the release. Before we start converting our application into a Helm chart, I want to do something important. I don't want to modify the project we built in episode 13. In real projects, we usually keep previous versions intact and create a new working directory for major changes. That way we can always go back to a known working version if something breaks. So let's make a copy of our Students Portal application and use that copy for today's Helm migration. Now we have 2 separate projects: the original application from episode 13 and a new copy that we'll use to build our Helm chart. Let's move into the new directory. First, let's take a quick look at the current structure. Right now, our application is organized as multiple Kubernetes manifests grouped by component. This structure is completely valid, but as applications grow, managing many YAML files becomes more difficult. That's exactly the problem Helm helps us solve. Instead of manually applying individual manifests, we'll package everything into a reusable Helm chart. Let's build it step by step. We just created our first Helm chart. Notice that Helm generated several files and folders automatically. Let's take a look at what was created. Helm gives us a starting point. The most important files are Chart.yaml, which contains metadata about our chart; values.yaml, where we store configurable values; and the templates folder, where our Kubernetes manifests will live. Since we already have our own application manifests, we don't need the example templates generated by Helm. These are sample resources created by Helm. For this project, we'll remove them and replace them with our own application resources. Now we have a clean Helm chart structure. The next step is to bring our existing Kubernetes manifests into the templates directory and start converting them into reusable Helm templates. We now have all of our Kubernetes manifests inside the Helm chart. At this point, we haven't converted anything yet. We're simply packaging the application using Helm structure. Let's verify what we have. Before introducing templates and variables, I want to show something important. Helm can already manage these resources as a release, even if they are still plain Kubernetes manifests. Notice that Helm deployed the entire application. Helm is now tracking all these resources as a single release. A release is Helm's way of tracking a deployed application. The installation was successful. Helm deployed our entire application as a single release called Students-Portal. If we look at the cluster, we can see that all components were created automatically. We have a backend deployment, a front-end deployment, and a PostgreSQL deployment. We also have the corresponding services for each component. At this point, Helm is managing the entire application lifecycle. What's interesting is that we haven't even started using templates yet. We're simply packaging our existing Kubernetes manifest into a Helm release. Let's see another advantage. Instead of deleting resources one by one, Helm allows us to remove the entire application with a single command, because Helm knows exactly which resources belong to this release. Now let's make our chart configurable using values.yaml and templates. The values file is where we store settings that can change between environments. Instead of editing Kubernetes manifest directly, we'll update values here. We'll start with something simple. Let's make the number of replicas configurable. This is our first Helm template. Instead of hard coding the value, Helm will read it from values.yaml during deployment. Helm is now generating Kubernetes manifests dynamically. The placeholders are being replaced with values from values.yaml. Notice that we didn't edit the Kubernetes manifest, we only changed a value. Helm regenerated the manifest and upgraded the application. Let's take a look at the final result. Our entire application is now managed by Helm. We have a front-end deployment, a back-end deployment, and a PostgreSQL deployment running inside Kubernetes. Earlier in the series, every change required modifying Kubernetes manifest directly. Now we can control application behavior through values and let Helm generate the manifest for us. This makes deployments more consistent, easier to maintain, and much easier to reuse across environments. We can install, upgrade, rollback, and remove applications using Helm commands instead of manually managing dozens of YAML files. This is why Helm has become the standard package manager for Kubernetes. But Helm offers even more than templating. One of its most powerful features is release management. Every deployment is tracked as a versioned release. Let's see how Helm keeps track of our changes and how we can roll back to a previous version if something goes wrong. Before we finish, let's talk about something important. We now have a working Helm chart, but where would we store it in a real-world environment? There are three common options. The first option is GitHub. This is the simplest approach and the one we'll use in this course. We store the Helm chart alongside our application source code. Team members can clone the repository, review changes, and install the chart directly. For personal projects, learning environments, and small teams, GitHub is often more than enough. The second option is Artifact Hub. Think of Artifact Hub as a public marketplace for Helm charts. It is maintained by the CNCF and contains thousands of open source charts. Projects like NGINX, Prometheus, Grafana, and many others publish their charts there. If your goal is to share a chart with the Kubernetes community, Artifact Hub is a great choice. The third option is an OCI registry. This is the modern and increasingly preferred approach. Helm charts are stored exactly like container images. The same registry can contain both your Docker images and your Helm charts. Examples include Amazon ECR, GitHub Container Registry, and Docker Hub. This approach integrates very well with CI/CD pipelines and enterprise deployments. So, when should you use each option? If you're getting started, GitHub is simple and easy. If you want to share charts publicly with the community, Artifact Hub is a great choice. And if you're working in a production environment with automation and CI/CD, OCI registries are typically the preferred solution. For our Students Portal project, we'll keep things simple and store our Helm chart in GitHub. That gives us version control, collaboration, and a central place to manage our Kubernetes deployments. So far, we've been installing the chart directly from our local folder. But in the real world, Helm charts are usually packaged and distributed. Let's see how easy that process is. Before packaging a chart, it's a good practice to run a validation check. Helm will verify the chart structure and report any obvious issues. Helm has created a compressed package. This file contains everything needed to deploy our application. This is the artifact we would normally store in a repository, such as GitHub, Artifact Hub, or an OCI registry. Even though it looks like a single file, inside we still have our Chart.yaml, values.yaml, and all the templates. Notice that we're no longer installing from the folder. We're installing directly from the package chart. This is exactly how charts are consumed in production environments. The application is running again, but this time it was deployed from the packaged Helm chart. This is the same package we could upload to GitHub or a chart repository and share with other teams. For this project, we'll keep our chart in GitHub. Anyone can clone the repository, package the chart, or install it directly from the chart source. In larger environments, this same package would typically be published to an OCI registry such as Amazon ECR or GitHub Container Registry. Now that our Helm chart is complete, let's add it to the repository for this episode. This way, anyone following the series can download the exact files used in the demonstration. The Helm chart, Kubernetes manifest, and application source code will all be available in the episode 15 folder. Let's copy everything into the project repository and prepare it for GitHub. Notice that I'm not committing the package chart archive. The .tgz file can always be generated again from the source code. What we really want to version control is the chart itself, including the templates, values file, and metadata. This keeps the repository cleaner and easier to maintain. Now the complete Helm chart is available in the repository. Anyone following along can clone the project, inspect the templates, and deploy the application using Helm. We started this episode with a collection of Kubernetes manifests, and we finished with a reusable Helm chart capable of deploying the entire application. In the next episode, we'll take the next step and move from a local Kubernetes cluster to Amazon EKS on AWS. We'll learn how to create a managed Kubernetes cluster in the cloud and prepare our applications for a production-ready environment. Thanks for watching, and I'll see you in the next episode.